Hi guys, today we are going to do oblique or slant asymptotes. And that is where the degree of the numerator is one more than the degree of the denominator. And in doing this problem, we are going to have to use some kind of a division process. And I don't really care what that process is. I'm going to do long division because that's what I like, but you can do whatever you want. I can have more than one degree. It could be a degree 2 bigger, would make the end behavior look like a parabola, and degree 3 would make it look like a cubic. But today we're going to be talking about only degree 1. Okay, so if I have the problem, y is equal to x squared minus 4 over x plus 3. Now the total degree of this is 2, this is 1, so that's how I get that. List your critical attributes. The vertical asymptote, in behavior asymptote in general, not horizontal, not vertical. It doesn't tell me, it's just in behavior. Whole, x-intercept, y-intercept, and the domain. I rarely will ask you for the range, but I'm always going to ask you for the domain because that's the undefined in the problem and you should be able to find that. Okay, so now I'm going to start finding what I know. Domain is x cannot equal negative 3. Okay, because it cannot equal negative 3, my vertical asymptote is x equals negative 3. Please make sure you're remembering to write the x equals. EVA must do long division for that. So that's going to be x squared plus 0x minus 4, a placeholder, x plus 3. So doing your long division. So subtracting out, negative 3x minus 4 minus 3, negative 3x minus 9. Change your signs, 5 plus 5 over x plus 3. This is your end behavior. So I would say y equals x minus 3. And I'm going to put this in. Okay, so I get a picture that looks like this. Please use dotted lines. That means it's not part of the graph. All right, the 5 will tell me something. I know that if I were to have 5 over x plus 3, that would graph in quadrants 1 and 3. So slanted, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. This is not really something you need to know, which is kind of handy to have a little bit of information with that. All right, factor the top, x minus 2, x plus 2. So there are no holes. An x-intercept at 2, 0, and negative 2, 0. And then the y-intercept would be found here. So 0, negative 4 thirds. Now this is easy. I can find my fence. And because it grabbed here, I know the next piece has to be down here. I could input negative 3 if I wanted to do that. I mean, negative 4. So that would give me 16 minus 4, which is 12, divided by negative 1. So down here at negative 12. But you don't have to be accurate. You just need to know that this piece is going to come down here. So that is one form of what this could look like. All right. If I have y is equal to x squared plus x minus 6 divided by x plus 2. Please notice that these equations that I'm using right now are all done in standard form. Because they are in standard form, that's easy for me to see which degree is bigger and which one isn't. So that's how you kind of have to think about that. If you start in factored form, you need to multiply it out. Again, what are your important parts of this graph? So make sure that you're always taking that into consideration when you're putting it down. So domain, x cannot equal -2. X equals -2 is my vertical asymptote. Do your long division again. X squared plus x minus 6 over x plus 2. And then I need a -1 to finish that part out. So -4 over x plus 2. So this time I'm graphing in a different space. So y equals x minus 1. Factor, so x plus 3, x minus 2. So no holes, but there is, oops, I did not put that in. So this is going to be what my slant asymptote is. Okay, x-intercept at -3, 0, and 2, 0. Y-intercept is here, so 0, -3. Now I can follow my lines down and then follow here. And just as I thought, it's going to graph in 2 and 4. This time it's easy to see the range. The range is all real numbers. This one is not so easy to see the range on because I have a gap between those two, and you would have to use a calculator to make that happen. All right, just one more. So if I have y is equal to x squared minus 6x plus 9 over x minus 4. Now you guys might consider stopping the recording at any point along the way and see if you can graph this by yourself. At some point, we need to make sure that you guys can do that. So stop, look, and see what happens with that. All right, so I know that my vertical asymptote is going to be at 4. Doing my long division. Carefully running through that problem. So my EVA is y equals x minus 2. Okay, my x-intercept. So factor x minus 3 squared. So 0, 3, I mean, about that, 3, 0. My y-intercept is here, -9 over 4, so that's right there. Okay, now I can see this does this, but now what happens, and remember in a polynomial, if you have squared, that means it bounces and it's going to come down. I know the next piece has to be up here, but if I plug in 5, I get 5 minus 3 squared, which is 4, over 5 minus 4, which is 1. So I know the 0.51 is on my graph. I mean, 454, sorry, is on my graph. And I know what comes up here. Please make sure that you have both parts on here. Okay, so now, just if we think about what our graphs need to look like, we should be able to write a possible equation, and the pattern comes with this. Your EVA is generally in the front. Your x-intercept factors are on top, and your vertical asymptotes from the bottom. A hole is on top, and a hole is on bottom. So when you're writing an equation, the first thing that you need to do is you need to find your factors. Once you find your factors, look for your multiples. All right, so if I started with an equation that looks like this. So y equals, there's a hole at -3, so I know I need to say x plus 3 on top and bottom. There's a vertical asymptote at -2, so x plus 2 is a factor that goes on the bottom. There is an x-intercept at 1, so x minus 1 goes on the top. There is a vertical asymptote at 3, so x minus 3 goes on the bottom. And there is an x-intercept at 4, so x minus 4 goes on the top. This is the degree, or the factors look the same, so I have like a horizontal piece. And if I look at each piece of this individually, this asymptote is an up-down, so a degree 1. This 0 goes through degree 1. This asymptote is up-down, degree 1. And that is go through a degree 1. So this would make a possible equation. Now there are a lot that you could have, but this one is a possible one. Okay. Now if I looked at one that's kind of a tad more complicated, same things hold true. First thing I want to do is find my factors. So f of x equals, I see an asymptote at 1, -1, that's on the bottom. I see a 0 at 0, so x. An asymptote at 2, x minus 2. A 0 at 3, so x minus 3. And an asymptote at 4. And a 0 at 5. So I know my factors. Now I'm going to go in and I'm going to look at my multiplicity. Okay, so when I look at this, that asymptote looks like 1 over x squared. So that particular asymptote needs to have a squared term that goes with it. When I look at this 0, it goes through the graph. That's a degree 1. This asymptote, I can see, and down, up, that's a degree 1 behavior. When I look at the 0, it bounces, and we know from polynomials if it bounced, then that factor is a degree 2. This asymptote is up, down, so a degree 1, and 5 goes through a degree 1. So 1, 2, 3, 4, 2, 3, 4. Both of them are degree 4, and that's in a behavior. They're the same. So that's all you got to do in order to make an equation. So hopefully you guys are going to have this was helpful, and you guys have a good day.